Team Daniel Iyamaremye, MSc Chemistry. Content developer, retired senior lecturer in chemistry with more than 35 years of teaching experience at university. Married, father of 4, grandfather of 6. Welcome. If you are viewing this video, I can bet that you like science in general, and particularly chemistry. So let's start by talking about Science Part 1. Matter 1. What is science? Science is the intellectual and practical activity that consists in the systematic study of nature through observations, experimentations, and measurements. 1.1. Subdivisions of science is 1. But nature is immense and complex. Science covers an extremely wide range of aspects so that it would be difficult for one person to cover all of them. That is why science has been traditionally or historically subdivided into 3 branches or subjects: biology, physics, and chemistry. Difference between the 3 branches of science. Biology is about the study of living organisms, humans, animals, and plants. Physics is the branch that studies the nature and properties of matter, forces, and energy. Chemistry is concerned with the properties of matter, changes of the properties of matter, its composition, and its reactions with other matters. But although those 3 branches are taught as different subjects, they overlap each other. And what about mathematics? Mathematics is not considered as a science subject, but it is indispensable to understand science. Indeed, science involves measurements, calculations, representations, and all this involves mathematics. That is why mathematics is called the language of science. Our lives and activities depend on those 3 branches of science and mathematics. For example, look at the street over there. We see cars running. Each car is driven by a biological driver who uses his muscles, brain, eyes, ears, etc. Each car has an engine that uses a chemical reaction between the fuel and the oxygen to produce heat energy. This heat energy is transformed into mechanical forces, another form of energy, to move the car. 2. Chemistry and the study of matter. But before we go into the study of matter, let's start by defining matter. Matter is characterized by 2 properties. It has a mass, or can be weighted, and it has a volume, or occupies a portion of space. 2.1. States of matter. In nature or in laboratory, matter appears in the following common forms, or states of matter: solid, liquid, gas. Each state of matter depends on the nature of the matter and the external conditions such as the temperature and the pressure. We'll see that later. 2.2. 3 states of matter is made of many small particle solids. In a solid, the particles are held together by strong forces, and those forces keep the particles in their positions. This explains why solids have a fixed volume and a fixed shape. In a solid, matter is compact, and that is why a solid is not compressible or almost incompressible. You cannot decrease its volume by applying pressure. Liquids. In a liquid, the forces between the particles of the liquid are weak, but strong enough to maintain the particles together. Because the forces are weak, the particles can move around one another without being separated. The particles do not keep their positions. This has 2 consequences. Liquids have fixed volume but no fixed shape. They take the same shape as the part of the container they occupy. The particles can slide one over the other, and that explains why liquids flow. In a liquid, matter is less compact than in solid, and its compressibility is very low. Gases. In gases, the particles are free. There are no or almost no forces holding them together. That is why they have neither fixed volume nor a fixed shape. They occupy the whole volume of the container. In a gas, matter is not at all compact, leaving a lot of empty space between the particles, and this results in gases being compressible. Changes of the states of matter. We know that each substance in nature exists in certain or state. This state depends on external conditions. For example, water is liquid at room temperature, about 20 to 25 degrees Celsius. Sugar and salt are solid at room temperature. Air is gaseous at room temperature. But if the external conditions change, the state can change also. For instance, although water is liquid at room temperature, it becomes solid, ice, if the temperature is below 0 degrees Celsius, and gaseous vapor if the temperature is higher than 0 degrees Celsius, 100 degrees Celsius. If you take an ice, solid water from the fridge and you let it warm, it melts to become liquid. If you heat the liquid up to 100 degrees Celsius, it will vaporize and become vapor gas. But you can also proceed in the opposite way, starting by the vapor. If you cool the vapor from any temperature higher than 100 degrees Celsius, when the temperature reaches 100 degrees Celsius, the vapor will start to condense into liquid water. If the temperature continues to decrease up to 0 degrees Celsius, liquid water solidifies into ice. The change of a solid into liquid is called melting, and the temperature at which a solid changes into liquid is called melting point, MP, or melting temperature. When we consider the opposite process of changing liquid into solid, the process is called solidification, and the above temperature is called solidification temperature or point. The change of a liquid into vapor is called boiling or vaporization, and the temperature at which a liquid changes into vapor is called boiling point, BP, or Boeing temperature. The opposite process of changing vapor into liquid is called condensation or liquefaction, and the temperature at which a vapor changes into liquid is called condensation point or temperature. There are few substances that pass from solid to gas and from gas to solid without going through liquid state. Those phenomena are called sublimation and deposition, respectively. NB. On the graph above, there is an error. At 100 degrees Celsius, water does not evaporate, it vaporizes. Evaporation is the natural phenomenon when water changes into vapor without heating. At a temperature lower than 0 degrees Celsius, water is solid. At a temperature between 0 degrees Celsius and 100 degrees Celsius, water is liquid. This is called melting. At a temperature higher than 100 degrees Celsius, water is vapor or gas. This is called boiling or vaporization. On the other side, if hot water is cooled from a temperature higher than 100 degrees Celsius, the following happens. At 100 degrees Celsius, water vapor becomes liquid. This is called condensation. At 0 degrees Celsius, water solidifies. This is called solidification or freezing. Attention! The change of state doesn't affect the mass of the matter under study. Those changes are called physical changes. 2.4. Evaporation and vaporization or boiling. The two words evaporation and vaporization bring confusion sometimes. In fact, they express the same phenomenon but in different conditions. Both words mean liquid, particularly water, changing into gas or vapor. Evaporation. Evaporation is the natural phenomenon where liquid water, or any liquid, changes into vapor or gas without heating. In other words, at local weather conditions. For example, if you drop few drops of water on the table and you leave them for a time, they will evaporate and disappear. When you hang your clothes on a rope outside after washing them, they dry by evaporation of water. Vaporization or boiling. The process of changing liquid into vapor or gas is not natural. It is provoked by heating the liquid up to its boiling point. 3. Water cycle and formation of rain. Step 1. Water cycle begins by evaporation of water from oceans, lakes, and forests. Step 2. Water vapor ascents or mounts in air. Step 3. As water vapor mounts high in altitude, the temperature decreases, and water vapor condenses to form small droplets of liquid water, and small droplets form clouds. Step 4. In the clouds, bigger droplets continue to form. Step 5. The big drops then are formed and fall back on Earth by gravity. That is the rain. As you can see from step 1 to step 5, it's a cycle, the water cycle. When the water cycle does not work for a long time, the region concerned experiences drought and famine.